What is up, great people? Back again with another video. It's Nosana, and some of you guys already know. In the previous video, I did a building and structural construction N5 BSC N5, right? On the previous video, I did a question on frame structures, and we calculated the reactions, right? The two reactions that we are given. So we were given the reaction on the RL, which was on the hinge, and then also on the right hand side, which was the RR for the rollers. So this was the first question of the question that I got from a past question paper, as you can see here. And we did question 1, right? We will do a recap shortly, but if you're watching videos from me for the first time, please care to like, share, comment, and subscribe. And also, if you are watching my videos and are learning something from it, please take a moment to comment, to like, and also subscribe, right? So that I can see that I am actually helping people. You know, it's just good to see, people subscribing, people liking, and also people commenting. The feedback is very important to know that my content is actually being seen by people, real people who are actually learning from it. All right, so thank you guys in advance. Let's get right to it. So I'm just going to do a short recap on what you need to do in order to calculate your reactions. Okay, just a quick recap on what you need to do, so pay attention. Right, so when it comes to finding out the magnitude, so this question here needs us to find the magnitude of the roof members, right? The magnitude and the direction, right? Not the direction, the nature. We need the magnitude and the nature, because when we're speaking about nature, we're either talking about a strut or we are talking about a tie, right? So when you say nature, right? Okay, when you say nature, you should just know that it's either a strut or it's a tie. By tie, you can also say tie beam. Right? So that is the main purpose of this question. So before you can even do that, you need to know the reactions, right? Remember, the reactions are basically what you are going to hold your roof member with, right? That roof truss, that is your reaction. So you'll have the left hand side and the right hand side, okay? And either one of the two could be the one with the hinge. So guys, you need to know how much weight, or force is each side able to withstand in order to calculate the whole roof truss. Okay, so this is what you need to do. The first thing that you need to do, or what you need to know when you are being asked to work with these questions. So this is the analytical method, right? Remember, in the previous video I did mention that there are two methods. There is graphical and there's analytical, right? So analytical, right? And then there's a graphical. The graphical method is the one that is complicated and needs you to be drawing. I will consider doing that, but later on, the graphical, method, right? So and then you have a graphical. I'm doing the analytical because, if you can understand the analytical, then you won't have much trouble, because you could find a question asking you to do either of the two. You can use the graphical or the analytical. So if you know the analytical, then you're sorted. But also, it's also important that you know the graphical, right? That you know the graphical method. I'm not going to discuss more about this, as I already did in the previous videos. So if you're working with analytical, what you need to know is to calculate. So I'm gonna say, yeah, must know, right? So must know. These are the must knows, right? So the first thing that you must know is to calculate your reactions, right? Calculate your your two reactions, right? You must be able to calculate your two reactions. But whilst we are still on calculating your two reactions, what you need to know, guys, is that you need to know how to calculate. Okay, before you even calculate your two reactions, what you will need to do is know how to draw a what we call a load diagram, right? So it's basically this is an example of the load diagram, what I have over here, right? I know there's a lot that is going on, but a load diagram is when you're taking the forces from the space diagram, they call it a space diagram, right? You're taking the forces or the loads from the space diagram and you are putting them on your load diagram, right? I won't go into much detail either on how to do the load diagram, but as we do more questions, you guys will understand it. And if there's anyone that needs a special video, right, or just a video that is explaining how to transfer the loads from a space diagram onto the load diagram, right, they can just mention it in the comment section and a video can be released, right? Because I need to know that this content is going to someone, right? So okay, guys, now what you need to know as well is to know that if you have a, right, so when you, to calculate your reactions, right, so no, you must know, right, how to draw a load diagram, right? You must know how to draw a load diagram, right? Diagram. It's not hard. It's not hard, right? How to draw a load diagram. We'll do more questions and just make sure that you subscribe so you don't miss out. And then the following thing that you need to know is what to do, right? What to do when you have, right? Is what to do when you have a hinge, right? When you have a hinge, right? When you have a hinge, or when you have wind loads, right? When you have wind loads. So this is what you will need to know when it comes to this, right? So this is coming from here, right? What to do when you have a hinge or a wind load or wind loads. So you have to divide or separate them in the different components. Remember, a wind load is acts on an angle, right? A wind load acts on an angle, and also a hinge does the same. It acts at an angle. Okay, the wind load acts at an angle, and also the hinge acts at an angle. So what you will need to do when it comes to the wind load, you need to separate it into a vertical and horizontal component, right? So wind load, what you need to do is separate it. Okay, right? So yeah, you need to separate it. Hey, okay, sorry about that. You need to separate it. I don't know if this is the spelling. We long finished doing English, right? So the load, sorry, the wind load, right? You need to separate it into its two components. You have the vertical. Okay, I mean I can spell vertical. The vertical, the vertical and horizontal, right? Vertical and horizontal, horizontal, vertical and horizontal components, right? Components. And guys, how you do that is not very challenging. You just separate it. So if you have a wind load acting, maybe okay, this is good. Let me just do this. Let's say you have a wind load that is acting. So for us, we need a strut, right? Let's just say we have a diagonal strut. It's acting at this point. Okay, that is to okay, it's acting at this point. We have our load. So maybe something else is happening here. It's doing that. And then our wind load is acting over here. Okay, so this is our wind load. Guys, what we do with this wind load is we separate it into the vertical and horizontal components like this. Okay, this is supposed to be vertical. So if you know your angle over here, if you know that this is, let's say, 30 or 60, that means that for the horizontal component, you will have the force, let's say 15 kilonewtons. The force will be your hypotenuse, right? The magnitude of that wind load will be the hypotenuse. And to get now your horizontal component, you will have to say 15, right? 15 cos 30, the angle Okay, and then the vertical component, as discussed in the previous video, I told you guys that if you have a difficult time remembering how to name the vertical component, just think of it as what happens when you die and you are not living a righteous life, and you end up being thrown into hell. And where is hell? Well, I told you guys that I grew up and I believe that hell was down there, right? So we can say sine, you'll say 15 sine 30, right? Sine for sin 30, and where do you go? You go down. So I think it kind of makes sense, guys. It makes sense. So that is how you separate your vertical and horizontal components, right? So you do the same with the wind load. I'm really sorry, guys, if I am moving fast, but I felt the intention of the video was to actually do the question, right? But now I'm going to break this video in half, just for you guys to understand this part, and then in the following video I am going to be completing this question. Okay, so that's what you need to know. You need to know how to separate your wind load and your how to separate your wind load into a vertical and horizontal component. Understand that you also do the same with the hinge. Okay, so if you can separate that, then on your load diagram now, what happens, or what is important for you to know about the load diagram is that if you have different forces, let us say that we have written it down, and then we have our hinge over here, right? We have our hinge like this, and over here we have our R, right? So we have RR is doing that. This would be our RR, right? And let me just say R hinge, okay? R hinge or RH, okay? So what happens now is, maybe let's say we have, now if you had a wind load on your truss, right? If you had a wind load on your on your truss, sorry, if you had a wind load on a truss, that means that, okay, before that, if you had any vertical loads that were acting downwards, right? By that I mean, if you had any vertical loads acting downwards, I mean like this 24 kilonewtons that you're looking at here. This is what we call a vertical load that is just acting naturally downwards. But now let's say now that you had a wind load, right? Do you see that if you had a wind load, this is how you would write it down, right? A wind load. So let's treat this as the wind load, right? So the wind load has two components. It has the vertical and horizontal. So if the magnitude was 20 kilonewtons, that means that the vertical component would be 15, right? So I'm going to write the vertical component on top. So it'll be 20 on 15. Let's just say 20 sine, right? Since it's acting downwards, sine what? Sine the angle that we have. Let's just assume sine theta. Okay, now it will depend now which angle, which side or which direction is that angle being applied. So if it's moving this direction, that means that now our horizontal component, so watch this yellow here, the horizontal component, okay, let me just do this. Horizontal component now, it will be let me just do this. It will be cos 15 cos, sorry, it will be 15 cos the angle, which is 30 in our case, right? 30, right? But remember now, we usually multiply these forces with the distance. So maybe if it was 5 meters over here, and then maybe it was maybe another 3 meters here, and then here you have, okay, so let me just see if I can put another force here, something like this, ne? And then here, let's just say 2 kilonewtons, right? Remember that what you will do to calculate the reactions, you will need to multiply the force with the distance that is between your starting point and where the force is, isn't it? So let's say, for example, we were over here on R and we were looking for, so if we're on R, we'll say that sum of, if you are calculating the RL, so you'll stand on R and say sum of, you look where RR is, you will notice that it's moving in the anti-clockwise direction. So you say sum of anti-clockwise moments is equal to the sum of clockwise moments. Okay, but now what I'm getting to is that when you're writing these forces, right, so you are standing on RH, so you say moments at RH, you can just say moments moments at RH. Okay, so to get moments on RH, you look across and you see that there's RR. See where it's going. It's moving in the anti-clockwise direction, as in from R. When you're standing on RH and you go across there, you will notice that RR is going in the anti-clockwise direction, right? It's going in the anti-clockwise direction. So you will start by saying sum of anti-clockwise moments is equal to the sum of clockwise moments, because remember, this whole system has to be at equilibrium. That's why you equate everything to, you know, the opposite. You equate the opposites together, right? So okay, now what you will have to do is, now I'm trying to explain about the distance, right, when it comes to the horizontal component. So pay careful attention. So here now you have RR. So I'm going to say RR. Now let's say here we had 6 meters. RR, you have to multiply it with the distance, isn't it? From RH to RR, what is the distance? It will be 9 plus 5, it will be 14, isn't it? It will be 14 meters. And then you need to find as well other forces that are acting in the anti-clockwise direction. But now what you will find out in this question that we just formulated, what you will find out is that you don't have any other forces that are acting in the anti-clockwise direction, or do we? Let's just look. So if you're over here, you're going this side. You see, you're starting moments at RH. You're going to look at RR. Do you see RR? RR is across, and what is happening on RR? RR is moving in the anti-clockwise direction, so it is going this way, isn't it? Okay, cool. Now you need to find out any other force that is moving in the anti-clockwise direction. Okay, let's find any other force that is acting in the anti-clockwise direction. When you look on number 3 there, the 2 kilonewton, you will realize that it's acting, this side is coming down, so it's the clockwise direction. And then when you move on, you also notice that okay, before that, look at the horizontal component of this 20 kilonewtons force that we assumed would be there, right? Look at what is happening. It is moving to the right, so to the right is like moving clockwise. And then look at now the vertical component of this 20 kilonewtons that we said. What is happening with the vertical component? The vertical component now, guys, what's happening is that it's acting down, yes, but now is it moving anti-clockwise? No. Go and put a finger on that load, right, and see. When you go down, you will notice that it's moving in the clockwise direction. Do you see that? It's moving in the clockwise direction. So you must put your finger on the load, like what we did here. We put our finger there and we notice that it's going this way, so it was going in the anti-clockwise. Here it is going this way, it's going down, right? Because there's no way that it's pointing down and then it ends up going up. Do you get what I'm saying? Right. So guys, if you're learning something, please like, comment, you know, don't be nice, right? So now we have realized that only one force is acting in the clockwise direction, right? So now let us focus on those that, anti-clockwise. Now let's focus on those that are moving in the clockwise motion, right? That are going clockwise. So we're going back. We can even start from here. We can see that this one is acting anti-clockwise, but now we have the 3 meters. So not 3 meters, you have the 2 kilonewtons. So you'll say 2 kilonewtons times the distance it is from RH, since you said moments at RH, right? You multiply it by what? By the distance from 5. Okay, so the way that I did this, guys, is kind of questionable, right, in a way, because if it's 5 meters, then okay, let's just do this. From here to here is 5 meters, and then, my goodness, okay, so yeah, over here, that means the distance in between here is 3 meters. Okay, let me fix that fast, right? Let me fix this fast. Okay, voila. Okay, cool. So that means that the distance, okay, now it just doesn't make sense, does it? I just moved it in the wrong direction. Let me try to shift it again. It should be somewhere here, ne? Oh, it should be there. What is happening, guys? What is happening? Okay, you know what? Let's just leave it there. And what we'll do to get our distance, we'll just say 5 plus 3, right? 5 plus 3, what do we get? We get 8. So we'll multiply it by 8, right? And then we say plus. Let's find another moment, another force that is acting in the clockwise moment, right? Well, what do we find? We find that if this is coming down and this is going there, this is also acting in the clockwise direction. Remember now, we discussed this 2 kilonewtons. Now we are over here. Let's start with the vertical component, right? The vertical component is just coming down. So we'll say plus 20 sine 30, right? 20 sine 30 times the distance. It will be 5 because from RH to there to that load, where that load is acting, is 5 plus 5, right? Right, I won't say meters. Now we need to move on and say plus. Guys, now we are doing the horizontal component. So this is the important part that stopped me from going through the video, that I had to make sure that you guys understand. So if you're working with the horizontal now, mind you, this is the horizontal component. It's moving in that direction. If you're over here, if you move that side, right, you realize that, or maybe if you start from where the load is starting over here, right, you will see that it is moving in the clockwise direction, right? So what happens now is that you're going to write it, you're going to say 15 cos 30, right? 15 cos 30 times, what are we multiplying by? We need the distance. So this is the important thing. You don't multiply the distance. You don't say the distance of the horizontal part. You see this part here, you don't use that distance. You use the distance that it is. You basically, you just use the height, right? You just use the height. So let's use this thing again. We use the height. So let's say that our 20 kilonewtons, do you see where the 20 kilonewtons is? The 20 kilonewtons, okay, let me erase this. The 20 kilonewtons is over here, and this is the height, right? So this is the height that you will need. You will need to multiply, instead of, for the horizontal component of the wind load of 20 kilonewtons, right? The horizontal component, you won't multiply it with the distance that you know from the load diagram. You multiply it with the height. The height of it will be the distance. So what height? The height is starting from the starting point where the force is acting to the truss, right? I mean to the tie. Do you see? So that is the height that you will look for. Okay, so that is the height that you will look for. Let's just come over here and assume that we know the angle is 30, and then we have the 2 meters. So to find the heights, we will just use the 10 ratio, right? To find the heights, we'll use the 10 ratio. And let's say you found out, we would see this was what's happening. If you had something like this, and then this was 30, right? 30, and then, okay, now it's looking weird. Maybe you had something like this, right? You had something like this. Okay, you had something like this, and then you had 30 over here, and now you are looking for the height, which is the opposite, right? And if you know this distance, the horizontal distance, that you will probably find it if you draw your space diagram, I mean your load diagram properly, because sometimes you're not given the measurements. You just need to draw your load diagram to scale, also draw your space diagram to scale, and then draw your load diagram to scale, and then the load diagram has to be under your what I'm saying, guys, what I'm saying is that if you have something like this, right, they don't give you the distance at all, you'll have to draw this according to the scale, and also draw the load diagram according to the scale, and just transfer the loads onto your diagram, right? Transfer the loads onto your diagram and measure the distance. Okay, and you measure the distance. Okay, so here let's just assume that our distance would be 2. If our distance is 2, then to find the opposite, we'll just say 10, right? 10 is equal to the opposite, which is the height in our case, opposite over adjacent, which is 2. So the opposite is going to be our height. So we'll multiply this now with the height, and this is where you're going to put your height. So in this case, our height would be 210 theta, the angle, which would be 30, right? That is what you do, guys. So here you would multiply this with 2, right? You multiply with 210 30 degrees, right? And then what you do after this, guys, is you just add, just pull your calculator out and you do the addition until you find out what the answer is. So when you find RR, that means you're sorted, and then you have to move on to finding your R hinge. Okay, you'll have to move on to find out what your R hinge is. And I'm just going to do quickly how to find your R hinge. right? So it's like I'm making the video twice, but this is for your understanding, eh? This is for your understanding, right? So now for the R hinge, it's a bit complicated, but not really. It's not that much, complicated. The R hinge, what you just have to do is to separate it in two different components. So do you see, for moments at RH, we looked across and we worked out for RR. So what we'll do now, we'll go for moments on R, we'll say moments at RR now. So we'll just say moments at RR, right? So we're going to look across, but now the hinge, we have to separate it into the vertical component, right? We'll have to find the vertical component. So what you can say vertical component of RH times the distance, right? So in this case, the distance is going to be what? You're going to stand over here on RR, since you said moments at RR, look across and find out how many meters is this apart. So it's going to be 14 as well, right? It will be 14 meters. Now you have to find out what else. Okay, guys, I forgot to mention anti-clockwise or clockwise. Okay, so sorry for that. So you need to stand on RR, look at R hinge, you realize that it's moving in the clockwise direction, right? So you'll say sum of clockwise moments is equal to the sum of anti-clockwise moments, okay, like that. And then what you will do now is you just look at your moments that are acting in the anti-clockwise, which will be your vertical component. So you say vertical component of what? Of your RH times the 14, which is the distance from RR to there. And then also find other forces that are acting in the clockwise moment, right? Find the other forces that are moving clockwise in the clockwise moments. You will find them. When you find them, it will be this force here. Okay, so you will stand over here. You'll see that this force is going that side, right? But then when you stand over here, this force is not going. Yes, and this one as well, actually. This one is moving. When you stand over here, okay, so if you're on RR, right, on RR, you look across, you see that this is moving in the clockwise direction. Okay, this one is moving in the anti-clockwise direction. Sorry about this, because you're coming back to RR. So it's moving, you going to RR, you're starting from here, and you're going to RR. Do you see that? So it's clockwise. Do you see? And then you come over here, you will see that this horizontal component of the wind load is also moving in the clockwise moment. Why? Because it's moving to RR. Now, when you see this vertical component of the wind load, it has to go to RR, right? So for it to go to RR, it will move in this direction, which, guys, is an anti-clockwise direction. It's the anti-clockwise direction. So over here, for the clockwise, it will be the horizontal component, which would be 15 cos 30 times the 10, right? You say times 10 to 10, 30. And then now you will have to do the anti-clockwise, which would be this force, and then it will also be this force, right? Because they are doing their own things, they're going in their own directions, right? So it was up until this point that I thought it would be better if I go over again, right? How to find out the horizontal component. So over here, you can be able to find the vertical component, and how you have to find the horizontal component is just to say sum of horizontal components, right? Sum of the horizontal components, you have to equate it to 0, and then find out, make the forces cancel each other. And by that, I mean that if you have forces that are going this side, equate them, add all the forces that are going to the right, and also equate them to all the forces that are going to the left, right? So you will take the ones that are going to the right, and then you subtract all the forces that are going to the left. But now you will have the horizontal component of what? Of your hinge as well. Guys, this is some interesting stuff, right? So I did do this in the previous video. For this video, because I'm noticing that it's also going over 30 minutes, it's better that I stop over here. And if you have any questions from this video, please don't be shy to comment. Don't be shy to message me on WhatsApp. My WhatsApp link is in my YouTube description. And if you've learned something from this video, please care to share, subscribe, and you know what to do, right? So thank you guys for watching up until we meet again in the next video. Now I promise that in the next video we are going to be doing the parts this part of the question that is asking us to find out the force and the magnitude, right? To find the force of each member and the nature, I guess, of each member. So it will be finding the force of AF, right, and also is it CF, and then also FE, right? So we just need to find out the nature and the magnitude of, or the magnitude or in the nature of those three, right, for 6 marks. So I'm going to do that video after this, right? So yes, guys, thank you for watching. Cheers.